Here we have an hypothesis test for me. So, in 98.6, average human body temperature. However, I've always noticed that when I'm feeling, my body temperature tends to be 8.6. So, for people, random sampling, I get to the body temperature. So, self-selection here, so people said no, relatively random sample. So I have 50, and the average 50 people was 90. Standard deviation 765. Those are measured in degrees Fahrenheit. So, idea of a hypothesis is the idea of a confidence interval, but they're related. For a confidence interval, according to my body temperature is 98, and then I would based on this data margin of error. And so I could do that with here. And so here I have error or an interval of 9.52 up to 9.04772. So big average human body temperature. And again, this is based on 50 people. So to find 50 people that has an average body of 8.6, that would be one of these samples in this. So it's in this fringe, right? Less than 0.5% from, so less than 2% as 50. Random sample of 50 is good, and that less than 2% an average of 6 or higher. So we have a confidence interval. Take the emphasis slightly off the sample and use some other assumption. And here the assumption is that it is 98.6. You have an assumption that a hypothesis. And null hypothesis, well, usually if you're questioning null hypothesis, that's the assumption. Human body temperature is 98.6. Alternative hypothesis, the population has a less than that. So that's the, since I'm doing less than, it's the left side. This is what's called a left hypothesis test. When we do a hypothesis test, we want a significance level. And the confidence level is going to be, that's pretty standard. It's not too low. We also, in a confidence, in a hypothesis significance level, this is always 1 minus. So it's the percentage, the percent. So if my 90%, my significant percent, my 9%, my 1%. And this determines the measurement unusual. And so usual for 5% or less of the time, or something happened 1% time. And it depends on the situation. We want these that unusual needs to be really small, percent less. It's not a thing. It could be 5% or 10%, somewhere in there. It's going to allow us to generate a value, and that's the probability sample based on your assumption. That is small and smaller than the significant, then we get to reject this and accept the alternative. Now we can neither hypothesis nor can we alternative hypothesis. All we can do is say evidence that we can even reject the null. Otherwise, what we can do is reject. So we have two hypothesis tests. Because we have enough evidence-based statistic, or reject the null. I mean, statistic is close enough to hypothesis that we really the hypothesis is true. It just doesn't disprove it. So we ran the same set of the hypothesis area of StatKey, and in this case, the confidence interval. I don't do endpoints. I just that are different in testing confidence intervals. One, the center distribution is whatever the null hypothesis, 98.6 in this case. And then the ability, the tail is going to be from this. And so in this case, tail, so 96 is left of the null hypothesis. The p-value is, in the case of stat, I did 6 samples of this data. So that means I have 6,000 samples each, and plot of the mean 1,000 samples is that only a small percentage of them, so 0.33 of the 6,000 up with an average 0.26 or lower. That's pretty unusual. Would you agree with that? My random sample is good. So probability that a random sample is less than 6 given the should be 98 point population. Now I have a good sample, such a small probability of something is wrong. Sample is good, then must be in my assumption that the should be 98 points. So what that means is evidence to say something believe that 98 point average. We get a problem random sample, and that gave us a very unusual have evidence because my p 0.00 then 0.05. And so I say I can reject the null. This doesn't always. So another possibility is that your data different averaged. My data set gave us 0.5. So simulation 6,000 times. So I have different samples and a mean in the sampling distribution here. Distribution a histogram also. Now I find that percent of samples that are equal to 98.5. That's 16 point. That's not unusual at all. If someone says, "Hey, $1 if you pay me," and you have a 16.8, I would definitely $100 for 16% chance of winning $1 million. Okay, so that's assumed. So that I sample, find the average body temperature 5, assuming 8.6. A sample data is close to the null hypothesis that the null hypothesis. I fail to reject the hypothesis. Happens either looking at evidence, meaning the probability of we got given assumption is so small, it's crazy. So we accept the alternative. Alternative is human body temperature 8.6 degrees. At the average is enough to the null hypothesis. We say, hey, null hypothesis. Really don't know. Remember, in statistics, prove anything to be. All we say is that chance that chance that we're wrong. There's a chance failing to reject this when it really is false, and that's still a possibility. Known as a type 2 error. Over here, if I reject the null, oh wow, look, this is unusual. 0.6 has got to be wrong. 98.6 is really is just a group of people. The temperature, so that's a type. You can make a, because there's a, you can never. All right. So is in StatKey hypothesis test, and then either the data set already, or I can edit and just highlight the place with my new data. I can upload a data file of working with data. But the data that's here. The difference in hypothesis test compared to is that I also have to state, so if it's not already given. Since I have a sample generating new sample, I generate at least 6,000. So here I have a sample. Every point here is shuffling original data set. And in this, whether I'm doing a right tail or a left tail test, here my null is that it's less than, and so that's a left. And then we do a right tail. Hey, it's just not equal to. Then I would do it, and that's a little tricky. The sample null hypothesis. We next need to our sample data. Data was that the was 98.26, and again that number is given sample 98.26. That entered in here. In this case, I find probability a sample that has a mean 26 or less, given that we expect 98.6, probability is 0.005. So shift that decimal twice, and we have 5% chance. That is wicked. So sample, what we can say that along with our assumption. I mean, it should be 98.6. In this case, we do have sufficient to reject the null, meaning the average temperature is 6, and accept that the mean is 98.6. Oh, sorry, 98.6. We're saying we know this, we don't. All we know is 98.6. Maybe it is 98.26. It's a point estimate. Now. So then I put an interval and saying, okay, evidence that the mean is 96. So now we're between 92 and 92, right? So that's my confidence. So the two can be used intervals in hypothesis. But the point of a hypothesis is to take that we have, look at a data, try and say there's something wrong with that assumption. That assumption might be right. Again, we can't prove it. All we can say is that's the assumption is incorrect, or is correct. That's the idea of hypothesis. Here we're doing that hypothesis simulations. Do it through formulas. Thanks. Do good math.